Okay, today we're talking about parallelograms. Yes, that great, wonderful word that as a young child you may have had trouble saying. Parallelograms. You may have said parallelograms or because this is one of those tongue twister words that I don't care who you are, at some point you've said it wrong. Okay, so we're going to investigate the features of parallelograms, and we're also going to talk about how you find area with them. Okay. So our I can statements that you need to get jotted down are I can use reasoning strategies and what I know about the area of a rectangle to find the area of a parallelogram. And I know how to describe the features of a parallelogram using mathematical vocabulary. So once you've got that, you're ready to move on. Don't forget to put today's date. Here we go. Take a look at these 6 shapes. Which of these are parallelograms? Okay. I hope that you said A, B, and C are all parallelograms, and D, E, and F are not. With the exception of E, all of these are quadrilaterals. Remember, a quadrilateral is just any 4-sided shape. A parallelogram is a little bit unique in that it has opposite sides that are parallel, and that the opposite angles are congruent or equal. So those opposite sides are parallel. They're also, besides being parallel, the same length. They're equal, or the fancy math term, congruent. And all of these fall in that category of a parallelogram. If you look down here, E doesn't work because it's 6-sided. That's a hexagon. D is just a quadrilateral. There are 4 sides, but it's an enclosed shape, but nothing's parallel. The only thing that we even have that we could say that is easy to identify is that we do have a right angle here, but all the other terminologies that we have for stuff doesn't necessarily allow for this to be something like this to be a parallelogram in any way. F is a trapezoid. We've got opposite parallel sides and then 2 sides that aren't parallel, so that's why they're not parallelograms. Good grief, I did it myself. So what's that mean for area? Well, when we talk about area with a parallelogram, we can think back to some of the things that we were doing the other day with manipulating those triangles to help us figure out. Yeah, if you said something like, or if you thought something like, well, if I make a triangle, I know that since this length, let me grab my handy highlighter here, this length and this length are the same, and that if I draw straight down, and I draw straight down here, that I make 2 sets of triangles that put together, I can take them and use to find out an area for this piece, as well as adding that to that area of this piece here in the middle. Same thing happens over here on this side. Okay, we can even still think about the same sort of thing over here on this side. Ooh, that's much better. So now we've got 2 sets of equal triangles that we can put together and make a square and help us figure this all out. Okay, so we've got 3 others here. How can we figure out the area of each of these? Try and figure them out. Okay, well, is A different than the other ones that we've done so far? Yeah, we've got, instead of our straight, just regular parallel lines on a line on our graph paper on the screen, we've got it going up and down instead of horizontal. We've got it vertical. And if we look at B, we've got a very skewed parallelogram as well. So finding it, we can still use kind of that same strategy we used the last time, couldn't we? What about B? Yeah, this one gets very difficult, doesn't it? We can't just slice off a piece and just move it where it goes to match up with something. It's not quite as simple. There may be a way, though, that we could find out what's going on here and maybe think about like an outside total area and then or figure out what a total area is and then subtract off some pieces of rectangles along the outside. Let me show you what I mean. So if I do something like this, and then I go from there, and I come straight up. And then if I do the same over here on the other side, I could go ahead and find the total area of that rectangle, right? And then find out what this triangle and this triangle has for spaces when I put them together and subtract it out of the total. And then that would give me this narrow strip. That is one of the ways to do it. But let's look at this bottom parallelogram here. Okay, so in this bottom one, we make a right triangle, don't we? And if I cut that off and move it over here to the side, it's just still going to take the same amount of space, right? But now make a rectangle. How are we going to know that that actually is true? Well, what do we already know about parallelograms? Yeah, opposite sides are equal, opposite angles are equal. So if all of that is true, then it really shouldn't make too much of a difference that we have graph paper or not. If we're told that this is a parallelogram, we should be good to go. Okay. And on this one, we know this side length, we know this bottom length, and we know this distance from the bottom to the top. Do you think any of this would help us figure out which ones are the area for this? Which of these three would end up helping us? Okay. Well, lots of good ideas. But when we go to solve this one, I want you to kind of think about, couldn't if I just slide set off, I move it over here? Well, if I know that this is 4 units, and now when I've got that all over here, and now I will try and draw. It won't be quite as nice, but now if that triangle is over here, isn't now this whole space from here to here still 6 units? Should be, yeah. Well, and this height is now 4. So even though that this angled line is 4 1/2 or 4 1/2 units, when we look at it, we're really only concerned about the actual height and this distance across from here, right? Okay. So I know some of you guys did some different strategies, and that's fine for figuring out this. We're going to actually talk about the mathy way to solve it out in our next lesson here. So real quick, parallelogram, get this jotted down if you didn't already. A parallelogram is a 4-sided polygon with 2 pairs of parallel sides. Okay, so make sure you get that jotted down. So in parallelograms, the opposite sides are equal in length, and they have, and they're also parallel. Remember, parallel just means that they will never touch. Okay. So today we talked about reasoning strategies about how rectangles we find area, and you relate that to parallelograms, and we talked about parallelograms. So we are all set. Make sure you've got all of your notes finished up and you are ready to go.